Okay, example number 2. I already read through the problem and I squared and circled everything that I thought was important. I didn't necessarily use certain colors for certain things, and I got kind of confused on this one because if you read the beginning of the sentence slash paragraph, it says that they have a fabricating department and a finishing department, and that made me feel like that was going to be my X and Y. But then if you look at the end of the paragraph, it says the company makes a $40 profit on downhill skis and a $30 profit on cross-country skis. So I was a little bit confused when I read this about what should be my X and Y. Is it going to be fabricating and finishing or downhill and cross-country? So if there's ever a problem that you're confused about what to be the X and what to be the Y, here's my clue. Your profit function always uses X and Y. Your profit function always tells you your variables. So the first thing that I do after I circle everything in the problem that's important and after I read it is make my profit function. So profit has to do with money. So money, sorry, I had to pause it because the announcement came on. But what I was saying is that profit has to do with money. So I always go back to my equation and my paragraphs and I find an equation that has to do with money. So the first thing I'm going to write is 40x plus 30y equals profit. Based on that, what is x and what is y? Ta-da! Don't you like how it just magically appears? So, profit has to do with money. I got my 30, I got my 40, which means x is downhill and y is cross country. That helps me know how to separate my information. So, now I'm going to write a list of everything that has to do with downhill and everything that has to do with cross country. Okay? Go ahead and see if you can make the list. I'm going to pause the video again. Okay, so hopefully you can see this. I just went through my sentences again. Downhill takes 6 hours of fabricating, 1 hour of finishing. $40 profit. Cross country is 4 hours fabricating, 1 hour finishing, $30 profit. Now I wrote fabricating 108 and finishing 24 because those two have to do with not just downhill and not just cross country. They're both totals that have to do with fabricating and finishing. So there's all of my information. Now, the first thing I got to do is write my inequalities. Every inequality comes from a total. So I always start with my totals. If I have a total of fabricating, that's 108, that means that one of my equations has to do with fabricating. So I'm going to create an equation. 6 downhill plus 4 cross country is with my 108 fabricating. So I'm going to use an x and a y. So 6x plus 4y is less than or equal to 108. Okay? The reason I use less than or equal to is because the department has 108 hours. So if they have 108 hours, I could use 108 or I could use less. I don't have to use them all. Then I'm going to write an equation on finishing. 1 hour of finishing for downhill, 1 hour finishing for cross country. 1x plus 1y is less than or equal to 24. And again, my total is 24. I can use all 24 or I can use less than 24. I'm not required to use them all. I'm definitely not going to go over 24. Now, there's one thing that's not in the word problem that is assumed, and so I want to tell you so that you assume it also. When you're creating things and when you're doing real world situations, you are not going to have negative numbers. So I can't make -2 downhill skis and -5 cross-country skis. So two inequalities or constraints that you have to add into your constraints if you don't have a minimum is that y has to be bigger than 0 and x has to be bigger than 0. Okay? Now, the reason that we didn't add these two in my last problem, in the example number 1 that I did previously, is that there was given a minimum. So in the other problem, if you remember, if you're watching these back to back, it said there had to be at least 3 of the large and at least 2 of the small, and that created my lower limits, okay? If you don't have any lower limits, you have to create two inequalities that make sure that you don't go into the negative numbers. And that's going to be important when we graph. So for now, just write it down, and as you do more examples, hopefully, you'll understand where we get those from. And again, we get them from the fact that you cannot make negative amounts of things. So if you're not given a smallest amount or a minimum, then you need to make an x that's greater than or equal to 0 and a y that's greater than or equal to 0. And it'll give you the other boundaries of your shape. Again, I'll explain that a little bit more once we graph. So the next thing I need to do is graph. I'm going to pause this video and I'm going to graph it so I don't take up all your time. I'm going to graph y equals 0 and x equals 0. And then I'm going to rearrange these so that they're in slope-intercept form and ready to graph. So go ahead and pause the video and rearrange these for yourself, okay? Okay, my work's right here, but here are the inequalities that I'm left with. So this is the first one rearranged, this is the second one rearranged, and then these are my two lower limit things from my not having negative numbers. So I'm going to go ahead and graph these, okay? If y is greater than or equal to 0, okay, and x is greater than or equal to 0, basically means that we're somewhere in this box, okay? We're greater than and greater than, so somewhere in the box. It just creates edges. Now, hear this very clearly, okay? This graph counts by threes. When I'm counting my slope, it says -1, which means I go down 1 over 1, down 1 over 1, down 1 over 1. Do not worry about getting every tiny little down 1 over 1. If this counts by threes, that's okay. So here's what I mean. If I put my y-intercept on 24, okay, and I have to go down 1 and over 1, I'm counting actual boxes on the graph, okay? So if I go down 1 box and over 1 box, I'm on this next corner, okay? You want to stay on the corners of your box. Now the reason why that works is because if you go down 1 over 1, down 1 over 1, down 1 over 1, if you go down 3 and over 3, that's the same, or that would simplify into -1, okay? So when you're counting your slope, use boxes. Down 1 box, over 1 box, down 1 box, over 1 box, down 1 box, over 1 box, okay? Don't let the slope mess you up. When kids are graphing, it's very hard for them to graph every single little point. Can you imagine the next one with the over 2? You'd be like in the middle of this box. It would be really hard. So please don't worry about counting exact numbers when you're counting your slope, but count boxes. So down 1 box, over 1 box. I've created my equation all the way across for that one right there. Now, if it's less than, it's going to be inside this triangle. So far, this triangle is where I want to be. I'm greater than 0, I'm greater than 0, but I'm less than this number. Because I take my 24, bigger numbers would go above, smaller numbers are below, so I'm shading below this line. So I'm in this box so far. Okay, I'm not going to shade it yet, though. I'm just going to put little dashes so that I know that I'm down here. Okay. Now, graphing the other one. Again, pay attention to me counting my slope. I'm going to start at 27. Okay? This means I go down 3 boxes and right 2 boxes. So I'm going to go down 3 boxes, right 2 boxes. Down 3 boxes, right 2 boxes. down 3, right 2. You should end up on the 18. And I'm going to attach this all the way across. Now, if I'm less than, I go to my 27 and I'm graphing less than this line. Okay? Now, the shape isn't a perfect shape this time, but it does have corners. Okay? So, the part of the graph that's shaded is inside those two lines. Okay? I have to be less than this brown and less than this green. So, this is my box. Okay? Now, the vertices or the corners are every corner that's on your graph. It's where two lines intersect. So this point right here is a corner. Okay? Then I go across this line and I get to another corner. And then I go down this brown line and I get to another corner. And then I go over and I get to the corner at 0, 0. Okay? It's a weird shape. Pause it if you need to. But we are following this green line, following the brown line, and then going across and going up. There's my shape. So I have 4 corners. Now, vertices are corners. So I don't care about this point right here because it's on a straight. And I don't care about that point because it's on a straight. The only points that we have to try as our like possible combinations are corners. So I'm going to write down the 4 corners. 0, 0, which is down here. This is 0, 24. This is 6, 18. And this is 18, 0. Okay. Once I have my 4 corners and my vertices of my shaded region, I'm going to take each one of these and plug them into my profit function. Now, if I'm trying to maximize the profit, is 0, 0 going to get me anywhere? No. So automatically you know that that would be wrong. Okay? 0, 0 gets you $0, not a maximum. Try again. 0, 24. I'm going to plug that in. 40 times 0 plus 30 times 24. Then I'm going to plug in 6, 18. 40 times 6 plus 30 times 18. 40 times 18 plus 30 times 0. I'm going to plug in each one of these. Ta-da! Magical answers. Okay, I got 720, 720, and 780. So, my sentence. To maximize the profit, you should make 6 downhill and 18 cross country. Max profit is 780. Okay? So, now I've done 2 problems. That's as hard as it gets. Okay? If you understand, fantastic. If you need help, that's what this video is for. Watch it until you understand the parts that you don't understand. Can you read the equation and create a profit function? Can you write inequalities given information? Can you graph inequalities? Can you identify vertices from the corners? Can you plug it into your final profit function and write a sentence? Okay, those are all the can-dos that you got to do. Lots of stuff in one problem, but you can do it. I believe in you.